My name is Kelly Popham, Technical Manager of Vino Engineering, LLC. Today I want to talk about steam costs. One of the most important benchmarks in the steam system is steam costs, and understanding what affects the steam costs. Why benchmark? Set goals to reduce the steam cost, so we want to implement energy measures to reduce that steam cost. Also, trend for changes in the system. So if we make energy implementation in the production, did it reduce the steam cost? Provides knowledge to make changes if the cost index changes. So if it goes up, we need to make change. Accountability. Charging the different production areas for steam usage. If we don't charge people for steam, it's free. Knowledge to all plant personnel. So it gives plant personnel knowledge. So if we go by this here venting to atmosphere, that the plant personnel can put a cost to that. So this here is costing the plant roughly around $55,000 a year. But if we don't have a steam cost, then venting has no impact to the system. And we needed to understand energy saving calculations. So if we're going to implement and reduce the steam cost, what is the payback for that implementation? What affects the steam cost? Well, of course, fuel costs. If we get lower fuel costs, of course, it's going to provide a lower steam cost. Operating steam pressure. Yeah, if we lower the steam pressure, it provides a lower steam cost, but it's not a significant amount, and we shouldn't be lowering steam pressure without looking at the boiler itself to make sure that we can lower the steam pressure without impacting the boiler operation. Also, we want to ensure the steam pressure is at the optimal steam pressure to meet the plant's process equipment. Percentage of makeup or percentage of condensate return. The higher percentage of condensate return, the lower the steam cost. So if you bring back 95% condensate, your steam cost is going to be lower. If you bring back 10% condensate, your steam cost is going to be much higher. The other thing is boiler efficiency. Higher boiler efficiency will provide a lower steam cost. Is the boiler operating at peak performance? Boiler efficiency is calculated at PTC 4.1. That's why it needs to have combustion testing of the boilers to make sure we're running at peak performance. And that should be done not once a year, it should be done every 3 months to make sure we're running at peak performance. Loaded and versus unloaded, or unloaded versus loaded. When establishing its steam cost, it is important to determine the true cost of steam being used in a steam system. That's loaded cost. What is loaded steam cost and unloaded? Loaded steam cost has all operational costs, labor, capital projects, manpower, fuel costs, transportation, chemical costs, water costs, all the costs built into it. Unloaded costs, just a basic information, fuel input, the sensible energy from the deaerator, which we'll talk about. Basically, this is unloaded costs. And so SE is steam costs, AF is fuel costs in million BTUs, HG is the enthalpy of steam in BTU per pound, HF enthalpy of the boiler feed water BTU per pound, NB, the true boiler efficiency per ASME PTC 4.1 in a percentage. The unload cost is basically a comparison of how much steam was produced and the cost of fuel. A basic equation, difference of the steam being generated by the boiler and the feed water, sensible energy coming into it, and the boiler efficiency. So, and an example of that would be just here is the monitoring point. So we have the sensible energy coming from the deaerator going into the boiler efficiency, cost of the fuel, and the total energy leaving the boiler. So just a basic calculation. So example, if the boiler is generating steam at 250 psi, 240 psi, which is right here at the boiler outlet, the de-aerator is operating at 15 psi, and the fuel cost is 4.5 or $4.50. The total energy is 1,201.8 BTU per pound. That is at the steam output total energy. The de-aerator is operating at 15 psi, so that's 208 BTU per pound sensible energy. And you divide by 1,000 and you divide by 0.79, which is the boiler efficiency is 0.79. And you come up with a fuel cost per 1,000 pounds of $5.60 per 1,000 pounds. Now, adjusting the fuel air ratio, making the boiler more efficient. So if we do that, we're still at $4.50 per pound, 79 cents, and we talk that our fuel cost is $5.60. But I do adjust the burner, the fuel air ratio, and I get the boiler efficiency up to 84%, and that will reduce my steam cost down to $5.27. So my point is the boiler should be checked for combustion efficiency at least every 6 months, or really every 3 months. But steam cost, no condensate being recovered, so we're not bringing back any condensate. Our steam cost now will go up to $6.44 per 1,000 pounds of steam. So, and that's makeup water at 70 BTU per pound versus the de-aerator. So it's very critical that we bring back all condensate. It really impacts the steam cost. The other thing is steam costs. You can have more than one steam cost. There are plants that are burning heat recovery or fuel coming into heat recovery boilers, and we're producing steam, which is going to have much lower costs. Some plants I deal with has 5 different steam costs, depending on where the steam's coming back. So the other thing is understanding the effects of not returning condensate. You know, we have gravity, low pressure, medium pressure, high pressure in the makeup water. So we can account for all these variables of bringing back different condensate in this equation here. So we just don't have one number, we can have multiple numbers. So, and that will help you out coming up with a much better understanding of the steam cost. We talked about unloaded, which was the basic equation that we just went through. Loaded, it takes in for many different generating expenses, operators, waters, chemicals, maintenance, administration, etc. Loaded cost is usually 2.5 to 3 times unloaded. So if you figure out you have unloaded at $5 per 1,000 pounds, loaded could be $15 per 1,000 pounds. So optimization, what happens on Monday? We need to calculate out the steam costs and be able to provide that to the plant for their knowledge. The other thing is that we have 70 best practices up at the website, 28 articles, and 24 instructional videos, just like the one that you're listening to right now. So please visit our website, and all the information up there is generic and no vendor information, just good engineering knowledge. We do long-term and short-term impacts to our customers. We do engineering assessments, steam balance and reliability, of course, engineering training. We do project design, project management, and full engineering support for anything steam and condensate. My contact information is followed. If we can be of service to you, please give us a call and have a great day.